Thank you for coming to my presentation. My name is Shinkanouchi at Megagon Labs Tokyo. Today, I'm going to talk about our work. You may like this hotel because identifying evidence for explainable recommendations. The purpose of our study is to explain evidences for vague requests by using review data. For example, in a hotel booking service, users often ask operators for vague requests such as a child-friendly hotel. To respond to the request, human operators need to explain the reason why the given request is satisfied. An example response would be, "This hotel has a large kids space, so I recommend it." Responding to vague requests with evidence is effective because it not only strengthens the recommendation but also urges users to make more concrete requests, such as, "I don't need a kids space, but I want a baby stroller rental service." Humans can do this easily, but it is difficult for chatbot. To do this, I made a dataset and conducted experiments. Explainable recommendation is a good way to improve user satisfaction. However, explainable recommendation in dialogue is challenging because it has to handle natural language as both input and output. There are several related works. Zhang et al. Generated explanations using a template with slots, such as, "You might be interested in the feature on which this product performs well." However, by handling only predefined and limited features, this study cannot explain detailed evidences for each hotel, such as a view of Mount Fuji and Lake Kawasaki. Zhao et al. Generated a recommendation sentence given a song name, author, and user tags as input. But the inputs were created from users' action histories or limited aspects, and the dataset is not publicly available. This is our contributions. First, we propose a novel and practical task to explain evidences given vague requests expressed freely in natural language. Second, we create a new dataset by annotating review sentences with evidences and rewriting each evidence into a recommendation sentence, and the dataset is publicly available. Third, experiments show that our dataset enables to train models that can be effectively find evidences to various vague requests and generating recommendation sentences. This is the contents. First, I explain an idea of our dataset. Second, how to make the dataset. Finally, experiments. To make a dataset, there are some data that I want. One is a list of vague requests, and the other is a list of evidences for the request. On the other hand, we have review data, and review titles often summarize the most salient point of the experiences and often include similar expressions to vague requests in dialogue. So we assume that some review titles express vague requests and that the corresponding review text contain the evidence. We extracted vague requests and annotated evidence sentences for the request in review text. Next, let's talk about our dataset. This is a pipeline to make evidence-based explanation dataset. First, we collect vague requests from review titles. Second, using review titles and text, we asked cloud workers to identify whether each review sentence contains evidence for the request. Finally, we asked cloud workers to rewrite each evidence sentence into a recommendation sentence. First, we collected vague requests from review titles. There are many kinds of review titles. For example, Good View Hotel, Beautiful Inn, Thanks, First Time. We want to remove noisy titles such as Thanks or First Time. So we extracted titles that contain some words such as hotel or inn. In addition, we extracted additional titles by using some rules. Because the amount of the collected title is small and imbalanced, we also applied filtering rules to remove other unuseful titles. This table shows examples of vague requests collected from review titles. We extracted about 1.4 million reviews. For annotations, we selected 37,000 reviews. By expanding the collection rules, the number of requests increased greatly, and the data imbalance problem reduced. Furthermore, it also includes the variation of the request expressions. Overall, we collected about 16,000 unique kinds of titles in 37,000 reviews. Using the extracted review titles and the review text, we asked cloud workers to identify whether each review sentence contains evidence for the request. Worker answered this question: is this given sentence relevant to the review title? And does it contain evidence for the title? And there are three options for the answer: evidence, relevant, and irrelevant. Relevant means that the sentence contains the same expression as the request or its synonymous expression, but it does not present an evidence to support the request. Although the evidence may make sense by combining two or more sentences, we annotated each sentence independently to simplify the annotation work. We annotated 37,000 reviews in total. For high quality, each task was annotated by 5 people. We also prepared check questions for each task. This table reports the ratios of the evidence and the relevant instance by category. In all, 55% of the reviews contained evidence for the request. In the useful category, 74% of the reviews contained evidence in the review text, while only 44% of the reviews in the cost category did. This is because users have to explain the reason for useful hotels. For example, it is close to the station, or there is a convenience store in the hotel. But for the cost category, users only sometimes explain why the hotel is cheap or expensive. We asked workers to rewrite each evidence sentence into a recommendation sentence. We annotated about 26,000 sentences that at least 3 of the 5 workers judged to contain evidence in the previous annotations. We asked workers to report in the following cases. A request is too negative to the recommended, or there is no evidence in the given sentence. This table shows the number of the exact matches of 5 workers for the created recommendation sentence. When only extracting a phrase from a review is sufficient as a recommendation sentence, the 5 workers tend to produce an identical result. On the other hand, when a certain part in a review had to be rewritten, recommendation sentence from the 5 workers tend to differ. Experiments. First experiment is to predict whether a sentence contains an evidence for the request or not. This is a binary clarification task. Positive examples are sentences that at least 3 out of 5 workers judged to contain evidence. All other sentences are negative. We randomly divided the data by review into training, development, and test set. We used Juman proper and byte-by encoding. We used logistic regression and BART model to predict, and we pre-trained BART model on 2 million review sentences. The input of BART model is request sentence, separator token, and review sentence. The F1 score of BART was about 80, which is 33 points higher than the logistic regression. We made sure whether the BART model considers a request when identifying the evidence. Thus, we trained another BART model without a request as an input. In that case, only a review sentence is given. The model trained without a request resulted in the F1 score of 43, which is 37 points lower than that with a request. This huge gap indicates that evidences in a dataset depend on requests, and the BART model pays attention to request properly. Since the dataset contained a wide range of requests, 30% of the requests in the test set are unseen and not appearing in the training set. Thus, we divided the test set in terms whether a request is unseen or not. The F1 score for unseen request drops by only 5 points. It is still high compared to the score trained without a request. This indicates that the model makes a successful prediction for majority of the unknown requests. Second experiment is to generate a recommendation sentence by using the evidence. We deleted common expression "I recommended this hotel because" before training. We compared one baseline and three models: no rewrite, a rule-based model, and two neural network models. No rewrite is the baseline where the evidence sentence is tolerated as the recommendation sentence without a rewrite. Compared with the baseline, all generation methods obtained higher blue scores. The score of the LSTM-based model is the highest. The blue score is 56. However, the blue score of the rule-based model was only 6 points lower than the LSTM model. This implies that this task requires fewer rewrites than we expected. The final experiment is to generate a recommendation sentence by using a request and a review text. If there is no evidence for the request in the review, we output a no evidence token. We use two models. One is a pipeline model. This is a combination of the task 1 and task 2. First, we predict whether each sentence contains evidence for the request by using BART. After that, using the highest score sentence of BART, we generate a recommendation sentence by using LSTM. If BART predicts there is no evidence, we output a no evidence token and end the process there. The other model is end-to-end model. This is only an LSTM model. If there is no evidence in the review, train to output only no evidence token. The pipeline method outperformed the end-to-end method, achieving a blue score of 45. It is 29 points higher than the end-to-end model. This is probably because the pipeline method could utilize the pre-trained BART model, and training the end-to-end method was difficult with very long sequence of tokens given as input. In addition, the end-to-end method tends to output too many no evidence tokens, and the total number of output words is low, so the blue score is also low due to brevity penalty. This table presents example of the generated sentences. In the first example, the both methods successfully generated. In the second example, the end-to-end method generated the natural sentence, but the recommendation is nothing to do with the request. Happy with my dog. In the third example, the end-to-end method generated the word pool, which was actually false because the review text only referred to hot spring. Conclusion. We proposed a novel and practical task to explain evidences given vague requests and created evidence-based explanation dataset. Future directions of this study includes choosing the best evidence sentence from multiple candidates, and verifying on other domains, and integrating it into an actual interactive recommendation system. Thank you.